Okay guys, welcome back to this video. Please don't forget to leave a like if you find the video useful and subscribing to the channel if you really enjoy the video. Subscribe, leave a comment and leave a like. Helps the channel to grow and pushes these videos further. So if we are coming back to still looking at templates, and today we want to look at template argument deduction and what does that mean. But we want to first start our C++ file, template argument deduction. Now this is what we want to talk about. Whenever we call a function template, like the one we've called in our previous video, like max, for given arguments, when it takes some template arguments, the template parameters are determined by the arguments we pass. And we talked about this, that the type deduction at the end of the day will be determined by the sort of arguments that we pass through our function we've determined, whether they are strings or integers. If we pass 2 ints to that parameter, then the compiler has to conclude that t must be an integer or an int. But there are cases where this type is only part of the type. For example, if we declare max to use constant references, and this comes into pointers, I'll write code and show you what I mean. So if we have template and the type name is t, okay, and with t of max, this time round our arguments are references, so we are passing a constant reference of a and t constant reference of b. If you don't have knowledge about what we're doing, it's okay, don't worry a lot. These are just pointers. A reference is an address within the memory of the computer. It's like we have that address really explicitly stated within our memory. So just think about it as an address within the computer memory. That's what a reference would be at a surface level. Now, if we perform the previous work we've been performing on max function, so if b is less than a, if b is less than a, just return a, otherwise return b. So you can see that we have references this time, but we've talked about the fact that the templates, the template parameters are determined by the arguments we pass. So if we pass ints to the parameter, the compiler has to conclude that t must be an integer. However, this time now, t might only be part of the type, whereby we now have a constant reference. So that means when we use a constant reference and pass int, again t is deduced as an int. So even here, the t will be deduced as an int because the function parameters match for int const. So depending on what we will pass in. So if we go into our main function and we write main int I equaling to 2, and well, I want this to be a reference, int I equaling to 2. Actually, yeah, let me pass that, int I equaling to 2. Then int ir equaling to I. But I want this to be a reference for some reasons. So if we print this out, let's see what we get. We are calling g++ main, and a we get 2. So Yes, we would expect that to be true. But the point is, what we are getting here is the return type is a constant reference of the argument that we've passed, of the arguments that we've passed. So even here, t is deduced, even here, t is deduced as an int. But in some sort of ways, it's a constant int, like where we declared it. So there's no way that we would, in between there during runtime, we would change that variable. Basically, that's what it would mean, that at runtime, that variable will not change. Okay. Then there is this another concept that we can talk about in this video, which we call type conversions during type deductions. And we need to note that automatic type conversions are limited during type deductions. So we cannot use keywords like, okay, we can, but they are limited. It's not good for your code. Words like auto, when you've not declared your variable or your type, sorry. For example, if we have something like this, so I want to look at those automatic type conversions. If we have like a 4 and a 7.2, let's put a scope resolution operator to instance of if I take this out, I hope still that isn't working. Argument types are int. Okay, it is complaining at, I wasn't expecting to complain at compile time. Argument types are int and double, and the function template max matches the argument. No instance of function template max matches. As you can see, we have an integer and a double, but max is declared as a template, but it cannot handle an int and a double. So for you, there are ways, or there are methods that have been provided by us, provided by C++ to help us circumvent this problem. And one of them is casting, what we call casting. Cast the arguments so that they can both match. And how do we achieve that? We can use static casting. And this is explicitly on this, we can say static cast, and we want to convert this into a double, and that means we are putting 4 into brackets, and yeah, the error goes away. So that means we have converted explicitly the 4 into a double by casting, or there is another way where specify or qualify explicitly the type of t to prevent the compiler from attempting to perform type deduction. And this would mean that we would, if we get rid of this, we can explicitly call this and say we want this to be a double, putting the angle brackets here after max, and we are converting everything to double explicitly. So let's see what we get from here. voila, like we expected. So these are some of the type conversions that happen, and it is always good to declare your variables, to define your arguments explicitly to avoid these dynamic type conversions. But what happens if you have multiple arguments? Well, we are going to look at all those in more complicated ways to how you can have multiple variables in the subsequent videos. So thank you guys for watching. Please leave a like, leave a comment, and tell me what you think about the video. Bye-bye.